Guys, how's it going? So today we're gonna be going through labeling techniques. So this will be more like a series. We're gonna go through in depth like labeling techniques. Then in the second video, we're gonna look at like the practical implementation of these labeling techniques. Maybe using a data set that is unlabeled. So I thought like I should cover labeling. I thought it was one of the most important concept in deep learning overall. After reading like a lot of use cases about projects that have been implemented by some of the giant tech companies, they attribute their success most of the time to having a very solid labeling system, and this is because I think most of these models that we train, they require very quality data. So having a quality data, it's quite important to be able to build a very robust and a good model. Tesla has a team of engineers who are actually specializing on labeling. So labeling, I feel like, is one of the most fundamental components for building an AI system. So the performance of like building a machine learning model still depend heavily on the quality and quantity of label data. So getting into like the different types and their challenges, the first tab that we're gonna look at is like hand labeling. So you can think of hand labeling as like we have some people who are like subject matter expert in the field, and they're going to label the data for us. However, the problem is that these people that we acquire, they can be quite expensive. So essentially, like let's say you're in the medical field, like you maybe need a doctor to label some of the text, for instance. However, to label that text about patient, it could be a private data. So now this hand labeling poses a threat to data privacy, which maybe in some countries this might not be allowed. So it kind of like make it difficult then to label that data from a human perspective. Just to give you some example that I've read about, Facebook, the DAG model, which is a model that detect abusive account on their platform. So what they do is that they had a human generated label. Also, they call this as like a high precision label. Then they had another labeling whereby they call that a low precision label. So they were using some sort of like roles and like there and other systems that they generate label for. However, they did mention that these high precision label, it's just a very small data. Like they couldn't like generate like big data because it was generated by human, and generating by human could be expensive, and. So the annotators at some point they had some sort of like a disagreement on which post were threat or a scam, something like that. So this is unexpected among annotators, and also if you can look at ChatGPT, they also raised around how they label their data, how you can have some sort of like annotator bias. I'll cover their techniques also and how they removed this bias, something like that. But the point that I'm raising here is that having like people to annotate the data for you and label if this is a thread post or not. There's going to be people have different perspective, so they might like disagree on certain things. So this is also an expected challenge that one can expect. So another technique that we're going to look at is called semi-supervised. So you can think of this as a technique to handle the lack of hand-labeled data. So we actually leverage assumptions to generate labels. So let's say, for instance, we have a small number of labels. So we're going to use that as a seed to generate more labels. So for instance, let's say we have a data set of like 8,000, right? And 1,000 from that data set is labeled. So meaning that we have 7,000 of unlabeled data, right? So what you do is that we train a probabilistic model on like that 1,000 labeled data, and we're just going to use the model to make predictions on the remaining 7,000. So we're saying that if we have high probability for those predicted, we're just going to add them to the training examples, right? So that's like how the semi-supervised supervision works. Now I want to get into weak supervisions, my guy. So this is where we leverage heuristics to generate labels, right? We can think of it as like, for instance, I made this example. Think of it from an Uber perspective. Let's say we have Uber Eats. Does it make sense for someone to make 100 orders in less than 2 minutes, right? It doesn't. Maybe someone makes like many orders in like foreign countries, right? And this will be classified as a fraud, right? So that's the point I'm making here, is that there's certain things that we can have as rules to say, okay, maybe someone make like 500 orders in less than like 5 minutes. Does that make sense? Is it possible for someone to make orders in like different countries like Brazil, USA, England, South Africa? It just doesn't make sense, right? So we can detect that as a fraud. So I like this Snorkel AI framework, which I quite like a lot. So what they do is that, okay, you can think of like we have a component of unlabeled data. Then we have some sort of like patterns, heuristics. We categorize them under the supervised weak supervision, right? Then these labeling functions that we write, what they do essentially is that it's just a piece of code that that output estimated label given a data point. So for instance, let's say we want to identify positive feedback from a customer email, right? So what we can do is that maybe we can say, okay, let's write a function. So maybe let's say identify feedback. Maybe we get the extract the name from the email, and we check if like this customer is existing in our database. Then what we do is that we perform a sentiment analysis. This sentiment function, what it does is just gonna look for phrases like thank you, thanks, something like that. Then what we do is that we say, okay, this is a positive sentiment, and we put this into our model, right? So for instance, in the medical field, what you can say is that, okay, if like a note, like right, a doctor note contained for pneumonia, then return emergency or something like that. So we're just gonna label it as emergent thing. So there are different types of these supervised weak supervision things that we can write as like functions, like this pattern matching, Boolean search, DB lookup, heuristics, legacy systems, and third-party tools. I feel like for me, the key takeaway is that with these label functions, I think that the thing that I really, really, really like is that we can actually label like so much data. And so unlike hand labeling, where you're expected to label like maybe like a few data, but with this, we can like leverage like a lot of, and we can do that in very, very, very fast and more efficiently, taking into consideration latency and compute. So that's what I like about these weak supervision model. I want to look into how big tech companies use label functions to label their data. So, for instance, Google uses internal name entity recognition model. So essentially, they use this to determine maybe, for instance, if a comment contains a celebrity or something like that. So there's a library called SpaCy, which I'm just going to show an example of. So what we have here, you can think like we have a text, and we're just going to apply name entity recognition. For instance, it's going to determine that, okay, Federal Bureau of Investigation is an organization. Then what is it? Iraq is a nation. Then I think, Iraqis Justice Department is an organization, and yesterday is a day. So that's what these entity recognition model they do. Again, Google uses like aggregate statistics. So this could be like if you want to like classify if someone maybe is abusing like or is abusive on like YouTube, you can look at like the number of times a user has been reported for abuse or something like that. So that's another thing that they use. So there's some people who don't know how to code. So Intel developed a spreadsheet-like interface for product analysts to express rules, right? Like it can be looking something like so. So you have a business scenario, type, polarity, and pattern. So this way, you get to still get to like have those rules, and then we can use these rules like to kind of like label our data. IBM and Apple, they have developed a UI for labeling functions. So now when I get into the class imbalance. So yeah, we spoke about labeling, but when we go to class imbalance, whereby for the most part, the positive class is usually like 0.1% or maybe less than 10%. And it's quite difficult to label the positive class for the most part, right? Like, so from a problem perspective, it is easy to write label function to identify positive class than negative class. For instance, let's say we have hate speech, right, which contains profanity. So, but for instance, like let's say we have a hate speech, but that does not have a profanity. So would we then classify that as a safe content, right? So for instance, and maybe I'm confusing here. I'm confusing you here. So what I'm saying is essentially, I went to YouTube and I made an example here, for instance, right? So let's say we want to detect these type of people on YouTube that scam, and they will say like Amazon token from, no, this is not true, right? But let's say we write label functions and say, okay, every time you see AM55X, just label that as like a fraud or something like that. But then next week they change. They say, okay, they detecting us now. They come up with like different name this time to actually to come up like with different token. So no, you just have to like continuously like go to your to your labeling functions and write these names that they come up with, and can be quite tedious task. I do get the point that you still able to get like the text, you know, like the text could be, they still use the same text to fraud people. It's not like necessarily a bad thing. You can still like be able to generate some sort of like good data from these, because in a way language models can be able to learn all of this text and see patterns and how these people write to defraud people. But that's the point that I was making here with like why it is difficult sometimes to label native class, for instance, right? So we thought a borderline example. So your label function will label your data set with obvious examples, right? And this could lead to overfitting, because now machine learning models, especially large machine learning models, are hungry for signals. So maybe this might lead to overfitting of your data. We developed a label propagation algorithm. So this was actually used to transfer information from the labeled data to unlabeled data. So essentially, all the unlabeled data gets a score weighted based on its neighbor labels. So you can think of pretty of like something similar to KNN in the way that all the unlabeled points, they rely on their nearest labeled data points. So for them to get labels. So for instance, if we look at this algorithm, is that we first start, we have like seed label data, right? Then we iterate to add more label data by actually making sure that all the nearest unlabeled data, the weighted get labeled. We iterate until we converge, until all of these points are labeled. So there are certain distance similarity algorithms like we can use, like the Jakarta similarity, something like that. So it is, so they developed this because they wanted to increase their recall. Okay, So what are the other techniques that one can use to label data? So one way you can go about it is that you can use unsupervised learning. I read the LinkedIn use case about how they detect abusive account. They're using isolation forest, so which is an supervised learning machine learning technique. So that's where you also can be able to detect like fraudulent account or something like that, right? So you do not have to label data. You can use transfer learning if you like. You have to classify some sort of like images. You can take a pre-trained model and you can freeze the end layers, or maybe just train the fully connected layer. We can use zero-shot learning. For instance, we can use GPT. So I just want to give credit to Kalen for these images. So what's going on here, I'm just going to zoom in, is that with GPT, you can have this thing called prompt guided and labeled data annotation. So essentially, you give it an example of like how, usually say you have text, tasty food, this is positive. You say text, horrible movie, this is negative. Then you give it a text to say poor facilities, then it has to come up with like a label. So it's going to say negative. So it's guided in the way that like you come up with text and sentiment, then it learns from your example that you just gave it. But another way we can do is that we can have this method called prompt guided training data generation. So what we do is that we tell it to write like a positive sentiment. So for example, we tell write a product review with positive sentiment, and it's just going to write like, okay, laptop is in good use, no heating issue, or something like that. So however, if we wanted to give like a positive feedback based on a specific product, or so we can actually tell it, and we call this dictionary assisted training data generation. So we have an entity, and we tell it that, okay, we want you to generate positive sentiment, but based on laptop, and it's just going to do that. So this is also called. But as much as it might sound like a very good technique to use, but these are quite expensive. Right. For instance, let's say I just did some sort of like analysis. Take this with a grain of salt, as I was using data from OpenAI. So what I did was that one API call for GPT-3 can cost you 0.00.10, which actually translates to $1 for 9,490 API requests, right? Bait was trained on 3.3 billion weights. So I'm just going to say, okay, we want like 100 million text for our label. So this can actually cost us something like $1,000, right? If like we want like 100 million text that is labeled from GPT, right? Maybe this 1,000 is not bad, but what's bad is that GPT can take 1 to 8 seconds to generate a text. In computer science, we always take worst case scenario. So let's say it takes 8 seconds. So we're just going to say one text, it takes 8 seconds. What about, because we said we want to generate like 10 million text, how long will it take us to generate that? It will take us to 2.5 years to actually generate our whole entire data without parallelism and like parallelizing the inference or something like that. So this is just maybe on one server. So it's quite expensive, right? So we can use it, but I think maybe if you want to generate a small data, maybe you can go with it. But yeah, there's some like techniques that are quite not expensive, but the accuracy of GPT-3 is quite mind-blowing at some point, and especially if you want like quality data. So you might actually be tempted to use it. Learning is one of the widely used techniques for its robust benefit. So I thought I should like create its own section and cover it separately. I think it's one of the most powerful techniques, and I've read a lot of use cases and how people have been using it and its own benefit. So I thought I should cover how it works and the different types, and yeah. So how it works is that you can think of like we're iteratively creating like label for a data set. Let's say like we have some sort of like a human um, in the loop. So we have some sort of like a seed. You can think of seed as like labeled data. So what we do is that we pass this labeled data. It's not enough. We want to label more data, obviously. So what we do is that we pass this data towards the model. The next thing, the model is gonna make predictions, right? It's gonna make predictions. Then we're gonna interrogate the model for insights about new examples, right? So what we do is that where we think we use those insights to actually be able to rank which of the labels, which of the examples we should label. So we send those examples to human, then human label them, then they pass them to the seed data. So you can think of it as like it's this loop that we have. It's just keep on going, right, until we have more powerful label data. So now we're gonna look at how we are going to rank these useful features. What are the techniques that we do, and what are the potential use cases for this method? Before I get into that, I just want to cover some of the types of like active learning. So the first one is that is the streaming sampling. So with the streaming sampling is that you can think of like we have a set of tweets that are coming in and we pass them towards the model. Then the model is going to tell us if we should label this and we should discard this. So as the data comes in, we feed it to the model, and we have a criteria to send them to a human annotator. Then the human annotate them. With pull request, we try to rank the entire pool of unlabeled data. So you can think of like we acquire entire unlabeled data and we run it through the model to produce the informative score. So if this is the labeled data, we run it through a model, then we rank this. Then we know that which examples should be labeled. So I like this diagram from Snorkel AI, whereby they indicate that, okay, you have a label data, you have input label, then you push this into a label data, and then you train your model. You use the model metadata along with unlabeled data, so that you can see which of the point should be labeled and which of the point the model is less confident on. Then you use a ranker model to then rank the labels or examples that should be labeled. So we create a label set that is going to be going to a human annotator to label that model. Then we iteratively go through this cycle. So one way we can be able to know which of the points in from the metadata is that whereby the model is not confident on, is that we can rather use like multiple model. So for instance, if like we have multiple model like that are separating these points, and this model is well separated by all the models, then we're going to give this a weight of zeros. That means this is fine. Then if a point it is being classified correctly by maybe 2, but 1 is not classifying it correctly, then we have to take into consideration. We have to take into consideration that. So that's why we use this formula to do that. However, the downside of this technique is that paving multiple models, it can be quite computationally expensive to do so. So what we're going to do now is that we're going to look at active sampling. So the idea here, instead of using multiple models to be able to classify examples which we are not sure of, we rather use a conditional distribution output by a singular classifier. So for instance, if we know that this point the model is 98 per sure, then this point maybe the model is 0.5 sure that okay, it's a negative class. So we can use these conditional distribution probability output to actually be able to assign these points or these examples and to go and rank them. But we attain the probabilities for our examples, what we want to do is that we want to assign them a score. So we want to turn the probability into some sort of like a score. So there are certain techniques under active sampling with uncertainty. One, we can use a least confidence. So whereby we try to say, let's assign higher weight for the example whereby we are least confident on. And another one is the margin, whereby we say that, okay, we're going to look at the minimum difference between high classes. Okay, after now we attain the score for each example, we want to then rank them so that we can pass them to the human labeler. So what we do is that we use techniques such as weighted sampling and top K selection. So this is going to give us, it's going to rank us there. It's going to rank all of the examples based on the score. But in a nutshell, these two components that we just discussed now, the distribution probability falls on this portion, then applying a ranking mechanism like weighted and top K sampling goes on the ranker, and that rank data goes into unlabeled samples. So you can think of this in simple terms as like we prioritizing the data that we are not sure on, and we just want it to be labeled so that our model can learn from that data. So yeah, I think that's all, guys, I have. I really appreciate your feedback. I'll try to cover more labeling content, as I believe that is one of the most important topic in AI overall.